All right, so we're going to be talking about some bisector theorems today, so perpendicular and angle bisectors. The first one, the perpendicular bisector theorem, says that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So what that is saying here is that if a point, so we're talking about point P here, is on the perpendicular bisector, so that's the vertical line there, then it's equidistant from the endpoints of the segments. So that means that the distance between P and A and P and B should be the same. So over here, we can add so if we know that all of these are the same, then PN or PA, line segment PA, is equal to line segment PB. So you can see those over here, and we would indicate that by putting the two little dashes in there to indicate that they are parallel. Okay, there's then the converse of the perpendicular bisector theorem, which states, excuse me, exactly the opposite. This says if we know that 2 points are equidistant, then they're on the perpendicular bisector. So that means that since we know that point A is the same distance to point P as point B is to point B or point P, so that distance there and then that distance there, those are the same, then what we know from there is that when we look at this side over here, we know that line PM, so we'll call this M down here, we know that's perpendicular, so PM is perpendicular to AB, which is a line segment, and we know that MA is equal to MB. So those two lines are parallel. Okay, and then talking about the angle bisector theorem, if a point is on the bisector of an angle, then the point is equidistant from the side of the angle, and the converse is the reverse of that. I'm not going to have you draw samples of that because it's really the same thing, just instead of being a perpendicular bisector like you see up here, so that's a perpendicular bisector, what you see is this is any angle bisector, so it doesn't have to necessarily be perpendicular right here. And what it does is that it means that it's equidistant. So here's the basics that you need to know then, is that if you know that these, so right here, this is the key point right here. MA is equal to AB. You know that's the same. So for example, if they were to say that this side is x plus 5 and this side is 2x minus 3, you could say that x plus 5 is equal to 2x minus 3, and you could find x. Also, if they were just to say that this side was 60, then you would know that this side over here has to be 60 because they're the same. MA is the same as MB. So what you really just need to know is when you're doing the problems today is all you're really doing is setting them equal to one another. All right, that's it. I hope today is more readable than the one yesterday. I made the font bigger, so let me know how it goes.